Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have completed the unit first of this subject. In this video, we are going to start the unit second of this subject named as Logic Gates and Boolean Algebra. Let's start our today's topic, logic gates. The logic gates are the basic building blocks of all the digital circuits. Logic gate is an electronic circuit having one or more than one input and only a single output. That means a logic gate is an electronic device which has number of inputs but it has only a single output. Okay? The relation between input and output is based on the certain logic. Let's see the classification of the logic gates. Logic gates are mainly divided into three types: basic logic gates, universal logic gates, and special purpose logic gates, or it is also called as the derived gates. The basic logic gates further divided into three types: AND gate, OR gate, and NOT gate. Universal gates has two types: NAND gate and NOR gate. The special purpose gates or the derived gates have the types XOR gate and XNOR gate. Let's see the details of each type one by one. The first gate is basic logic gate, NOT gate. It is also called as an inverter because its output is the inverted version or the complement of its input. This is the symbol of NOT gate. Okay, this is the symbol of NOT gate. Whatever the value is at the input, at the output, its complement is obtained. That means if the input is 0, then output is 1. Input is 0, the output is 1. If the input is 1, then the output is 0. Okay, I hope you all understand. In any logic gate, some things are very important. That means its symbol, its truth table, and its logic equation or its Boolean equation. The symbol of NOT gate is shown here. The truth table is here, and this is the mathematical equation or the Boolean equation of the NOT gate. Okay, the next gate is AND gate. It performs logical multiplication on its input. This is the symbol of the AND gate. That means there are two inputs, and this is the symbol of the AND gate. If A and B is the input, then at the output we get A into B. Logical multiplication operation is performed. This is the logic equation or the Boolean equation of the AND gate. Its truth table is A and B has the possible value 0, 0, 0, 1, 1, 0 and 1, 1. That means 0 into 0 we get 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. That means if any of the input of the AND gate has the value 0, then its output is 0. Okay, here we can construct the three input AND gate, such as this is the symbol of three input AND gate: A, B, C, A, B, C, and it has the single output. Its equation is y is equal to A into B into C, and we can construct its truth table, such as 0 into 0 into 0, it has the value 0, 0 into 0 into 1, it has the value 0, 1 into 1 into 1 up to it has the value 1. I hope you all understand the AND gate. The next gate is OR gate. It performs logical addition on its input. This is the symbol of OR gate, and A plus B, that means OR operation, is the Boolean equation of this OR gate. The truth table of the OR gate shows 0 plus 0, 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. Okay, that means any of the input of the OR gate has the value 1, then output is 1. Okay, I hope you all understand. We can construct 3 input OR gate such as it has 3 input A, B, C, A, B, C, and single output Y, then its equation can be written as A plus B plus C. We can construct truth table for the same. A has the value 0, B has the value 0, C has the value 0, then output is 0. Output is 0. If A has the value 0, B has the value 0, C has the value 1, then the output is 1. Up to A has the value 1, B has the value 1, and C has the value 1, then output is 1. I hope you all understand. The next gate is, or let's see, the overview of basic gates and or and not gate. This is the symbol of AND gate, this is the symbol of OR gate, and this is the symbol of NOT gate. Okay, in AND gate the logical multiplication is performed, in OR gate logical addition is performed, and in NOT gate the complement is performed. Okay, I hope you all understand. The next logic gate is universal logic gate, NAND gate. NAND gate is formed by combination of AND gate and NOT gate in series. That is, by connecting the output of the AND gate at the input of the NOT gate. That means this AND gate is connected with the NOT gate and we get the NAND gate. This is the symbol of NAND gate. Okay, let's see once again. If this is the AND gate, the output of the AND gate is connected with the NOT gate's input, we get NAND gate. If A and B are the input of the AND gate, its output is A and B, and we know that NOT gate is used to complement, hence at the output of the NOT gate we get A into B bar, hence the output of the NAND gate is A into B bar. This is the Boolean equation for the NAND gate, and its simplified symbol is such that this is the symbol of AND gate. We know that A and B. Place bubble here. If we place bubble here, then it becomes the symbol of NAND gate. I hope you all understand. Okay, here is, this is the symbol of NAND gate, and its logic equation is A into B bar. Let's see its truth table. This is the logic symbol A into B connected with the NOT gate, and this is the simplified symbol. Okay, this bubble is shows that this is the NAND gate. A and B has the value 0 0 0 1 1 0 1 1. We know that A into B, that means 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 0. And if we again complement it, 0's complement is 1, this 0's complement is 1, this 0's complement is 1, this 1's complement is 0. Okay, that means the truth table of the NAND gate is 1110. I hope you all understand, and this is, it is very simple. That means this is the truth table of the AND gate and this is the truth table of the NAND gate. These are complement of each other. That means 0's complement 1, 0's complement 1, 0's complement 1, and 1's complement is 0. Okay, I hope you all understand. The next universal gate is NOR gate. NOR gate means not plus or plus NOT gate. NOR gate is formed by the combination of OR and NOT gate in series, that is, by connecting the output of the OR at the input of the NOT gate. This is the symbol of NOR gate. Okay, how is it constructed? Let's see. This is the two input OR gate. It is connected with the NOT gate. That means A and B are the input of the OR gate. At the output of the OR gate, we get addition of A and B. At the output of this NOT gate, we get its complement A or B, A plus B bar. This is the Boolean equation of the NOR gate. That means A plus B bar is the Boolean equation of the OR gate, and its simplified symbol is this is the OR gate, and placed a bubble here, then it becomes a NOR gate, A plus B, and its output is A plus B bar. I hope you all understand. Let's see. This is the logic symbol of NOR gate. A and B has the possible combination 0 0 0 1 1 0 and 1 1. That means 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. If we again complement this 0, then we get 1. Complement this 1, we get 0. Complement of 1, we get 0. Complement of 1, we get 0. The 1 0 0 0 is the truth table of NOR gate. Okay, the next gate is derived gates or special purpose gate. The first gate is XOR gate. XOR represents the inequality function, that is, output is true if the inputs are not alike, otherwise the output is false. Its Boolean equation is A XOR B or A bar B plus AB bar. Okay, this is the symbol of XOR gate. If A and B are the input, then output Y is equal to A XOR, this is the symbol of XOR, A XOR B. That means we can write this equation as A bar into B plus A into B bar. This is the Boolean equation of the XOR gate. Okay, now let's see the truth table of the XOR gate. If A is 0, B is 0, we know that the equation of the XOR is A bar into B plus A into B bar. That means A bar has the value 1, okay, B has the value 0 plus A has the value 0 into B bar has the value 1. 1 into 0 is 0, 0 into 1 is 0, and 0 plus 0 is 0. We get 0 here. Okay, I hope you all understand. Now let's see next case. This case A bar, that means A bar is 1 dot B is 1 plus A has the value 0 into B bar has the value 0. 1 into 1 is 1, and 0 into 0 is 0. 1 plus 0 is 1. This is the second case output. Let's see third case. Third case is, this is the third case. A bar has the value 0, A bar has the value 0, B has the value 0 plus A has the value 1, and B bar has the value 1. That means 0 into 0 is 0, 1 into 1 is 1, 0 plus 1 is 1. Okay, the last case is this is the last case. Let's see, A bar has the value 0, B has the value 1 plus A has the value 1, and b bar has the value 0. That means 0 into 1 is 0, 1 into 0 is 0, and 0 plus 0 is 0. I hope you all understand how to obtain the truth table of XOR gate. If we look carefully at the truth table of this XOR gate, then we can see here, if both the inputs have the same value, that means if the both input have value 0 0 or value 1 1, then its output is 0. Okay, if the inputs have the different value, that means 0 1 or 1 0, then its output is 1. I hope you all understand. The last gate is XNOR gate. The XNOR function is logically complement of the XOR gate. Logically, an XOR gate is NOT gate followed by an XOR gate. That means if we place a NOT gate after the XOR gate, then we get the XNOR gate. This is the symbol of XNOR gate. It is very simple. This is the symbol of XOR gate, and if we place a bubble here, then it becomes XNOR gate. The logic equation of the XNOR is shown here: a bar b plus ab bar bar. Okay, its truth table is, we know that the truth table of XOR gate is 0 1 1 0, and if we complement this 0 we get 1, complement of 1 is 0, complement of 1 is 0, and complement of 0 is 1. This is the truth table of the XNOR gate. I hope you all understand all the types of gates. Thank you.